All right, welcome to the final session, except for the birds of a feather afterwards. Unfortunately, there's no more drinking, so bad luck. Okay, I didn't write any notes for the 12d XML because I didn't know I could really fill up more than 5 minutes on it because it's really quite simple, actually. Let's just go and do something very simple, like we'll just create a line string. Bang, bang. We're now going to export that, and probably in my version it's subtly different because I went and combined the 12d XML and 12d archive into one option. We're just going to go do that simple model that we just output. I don't want the zipped version because we want to look at it, and we'll just call this test. Then we'll go do the XML version. And again, same model, and I guess we'll call it test. We'll now go and open these two files up, and we'll just have a quick look to show you what the real difference is between ASCII and XML. And you'll ironically see that probably Lee and I were quite forward-thinking in what we did many, many, many years ago with the 12d ASCII definition. I probably need one of those cute editors that synchronises the line numbers on both files. What was that, Ultra Edit or something, Rob? Okay, so if we scroll down the bottom, oh, that file's not long enough, okay. If we get into the guts of the ASCII, you'll see we put some comments up here. In the XML, basically we have the same comments, but they're in a, for those people that don't really understand XML, each one of these things that you want to call, which have triangular open close bracket, that's known as an element. So here under metric, you'll see the equivalent metric at the bottom. So some of this guff where we say, well, this is the version of 12d ASCII that we output it with and the application date, we now put that in an XML element just so that it's more easily parsable. And then some of the comments are similar there. If we get down to the guts of the actual file, you'll see the 12d ASCII just says, well, this is the model I'm starting and here's my superstring. The XML is subtly different in the fact that it says, here's my model I'm starting, here's the name, and then here's my superstring. Now if you go line for line, superstring, superstring, name, name, chainage, break line, color style, dates and times, or sorry, times of creation and update, and then your data 3D. The only subtle difference here is in the XML, we're making it a little bit easier for the DOMs and the XSLTs by each point within this superstring is in its own little P element, P for being for point. But other than that, you can take the 12d ASCII documentation off the website and almost line for line correlate it with what the 12d XML is. So there shouldn't be too much of an excuse for other vendors going, oh, you know, they made this huge change from ASCII to XML and it's going to take us years to do stuff. As Phil Campbell showed with his access stuff. He was using, well in this case he was using the 12d ASCII. In all Microsoft products, they all have inbuilt XML readers. So his life actually would be easier using XML than it would be for ASCII. Tony Ingle, for the IFCs to Revit, he was using the XML because there's heaps of tools out there for reading XML and doing lots of funky stuff with it. You'll see more and more of a theme as each version of 12d comes out. We're migrating more and more things over to XML. You might sort of think, oh, yeah, we've had a lot of complaints about just about every file we've changed from an ASCII to XML, but after a while they go, actually that was a good idea because we can now do all this stuff that we couldn't do previously. So I'm probably going to disappoint Lee here and just sort of go, well, what else can I say about XML? He said very little, so gee, number one of 3 off the list and it didn't crash. Actually, there is a couple more things I probably could say. Under the file input, well, obviously we now have readers, but the one thing that we got Ben to do, it was a horrible, painful job, but he wrote a 12d XML to 12d ASCII converter. So we can just take that test file there and we'll dump it out to, here we go, your name's up in lights, Ben. And if we go and now open up that ASCII file, it looks much like the file we wrote out before. So we also do have that type of tools. Now, you could do this with XSLTs for people who understand that. XSLT is just a language to say, I've got an XML file and I want to reformat it somehow. You can reformat it into XML, you can reformat it into text files, to CSV. I think Han and others have probably showed you that usage throughout the actual conference. So hopefully by now you're starting to get the idea of that type of idea. We didn't use XSLT in this case because the temptation was there, but what happens once we start dumping out mega huge projects of 10 gigabytes, 100 gigabyte XML files? So we've actually used what's called a SAX parser, which is just sequential. It never has to load more than a couple of K of the file into memory, and it just steps through it piecewise. And so our XML to ASCII converter is quite efficient. So it can do 100 gigabyte files, terabyte files, and it shouldn't crash. Isn't that right, Ben? So if it doesn't work, he broke it.
Stand up, Ben.
Stand up, Ben. All XML questions on the 12d XML, he'll sort them out. So yeah, really in terms of...
Yep, so that is about all we can say.
That's about all we can say, really.
Takes any blame, that's the main thing.
Yes, yes. So it's really unexciting, but for I think a lot of people, they'll be going, oh wow, that makes the 12d archive data or the 12d ASCII, the 12d XML data, we're not too sure how to merge those into one name. I suppose 12d archive data probably almost still works. That just opens up a huge world of potential new tools that you guys can come up with good ideas, and maybe at the next Innovation Awards there'll be something on, we took all these different XML files out of 12d and did this. We shall see. Okay, so that's that little XML out of the way.